Howdy folks, we're back and we're going to be looking at chapter 13, section 13.1 for Math 120. And we're going to be getting into money. So the time value of money. And so did you bring a scientific calculator? And the reason it's asked because you're going to need one. So if you don't have one, you might want to check into getting one or at least downloading one of the free apps that have a scientific calculator. Okay, so we're going to start off with some terminology. We're going to look at interest. So whether money is loaned out or deposited in the bank, the amount of money grows over time. We all know that, right? The increase in the value of money is called interest. The original amount of money is called the principal. Usually money increases based upon a specific percentage. So it's going to grow a certain amount, but it's going to be based off of a percentage of what you're depositing in there or what you're taking out. So this percent is called the rate of interest or the interest rate. In general, we can examine two types of interest. If the interest is calculated based on the principal alone, it is called simple interest. Likewise, if the interest is calculated based on the principal plus any previously earned interest, then it is called compound interest. So let me try to explain that a little differently. So if you're looking at simple interest, you're looking at basically one time frame to calculate the interest. So usually the life of the loan, if it's a year or 2 years or whatever, you take the whole period of time and you calculate the interest over that one period of time. Compound interest breaks that time up into smaller chunks and it finds the interest at specific intervals throughout that overall lifespan of the loan. So it's going to do something to the interest. I don't want to give it away, but we're going to see that in an example later on. But let's start with the simple interest because it's simpler. So a couple of the notations we need. So we're going to use capital P to describe the principal. We're going to use R to describe the annual interest rate. So again, that's the percentage. And then T is going to be our time. And the most important thing is that it has to be in years. So if the time is not in years, we're going to have to see how to fix that. So if we have all of those variables, then the simple interest I is calculated as follows. So I equals P times R times T. Very, very quick. So as long as you got your calculator handy, we should be able to rock through these nice and fast. All right, so let's start with the first one. So find the simple interest earned or owed for each loan. So in this case, they borrowed the money and then they're going to have to pay it back with interest. So how much interest are they going to have to pay back? So if we plug all of our numbers in, we're going to have I equals 800. Now percentages, you're going to have to change those to decimals for this application. So every time. So in this case, we're going to write 0.06, and then we're going to times that by 1, which doesn't change it. So if we multiply all that out, we should get 48 bucks, but let's double check. So 800 times 0.06 times 1 equals 48. So it is $48. And again, units are important. This is all money. So don't forget your units. All right. Now for this one, it's not in years. So now the first thing we have to do is say, okay, well, how do we rewrite this in terms of years? But because it's in months, well, how many months in a year? 12, right? So all you have to do to change it into years is divide it by 12. So we're just going to say 9 divided by 12, and that will be years. Now, in this case, we could divide that to get a decimal. So if you wanted to do that, you could divide and get 0.75, and that's fine. But you don't always get a nice decimal. So in those cases, you want to be really careful because you don't want to round things off while you're doing the problem because that's going to affect the final amount of money that's going to be generated. So you want to be careful of that. So we'll see some examples of how to take care of that in a minute. So the first thing though, let's plug in our principal. Let's plug in our interest rate. And if we want to use 0.75, we can. And now let's multiply all that out. So 920 times 0.07 times 0.75 equals 48.3. So now this is money, so this should be $48.30. And that's it. So that's how much interest has been generated over a 1 year time frame. That's how much interest has been generated over a 9-month time frame based on this interest rate and this principal. So, okay, so let's look at some more terminology, future value and present value. So in the previous example, $920, which was the principal, can also be considered the present value of the loan, whereas the future value is calculated by adding the present value and the calculated interest. Thus, well, let's see what happens. So if we wanted the future value, it's going to be equal to the present value plus the interest. All right, so if we wanted to know what that future value was in this particular example, basically this one up here, we would say $920 plus the $48.30, which gives you a grand total of $968.30. So if you borrowed $920 from the bank under these stipulations, you'd have to pay the bank back what you borrowed plus the interest. So that's what you would have to pay back, $968.30. So it's a little bit more information than just knowing the interest alone. You get that total lump sum of what you have to pay back. So let's take a look at a couple of formulas for that. So if we wanted the future value for simple interest, so we got P is still the principal, which is still the present value, and it's borrowed at simple interest T years at an annual interest rate of R, then the future value of the loan denoted by A is calculated as follows. So A is going to be the global variable for future value. So anytime you see A, that is always the future value. All right. So this is one way that we can calculate it. Now we did it a little differently up here because we just said the present plus the interest. So that's another way we could also do it. If you take your principal plus your interest, it's going to give you the same thing. It should still give you that future value. All right. But like I said, this formula is just a little bit nicer. It seems more complicated, but it really isn't. And it just encapsulates it all a little bit differently. But like I said, either one of these will give you the same result for simple interest. When we go to other types of interest, it's not necessarily going to be more than one option. But let's see what happens. So for number 2, they want you to find the future value of each deposit if the account pays simple interest. So there's the 2 checks. They want the future, and it's for simple. So we know the formula is A equals P times 1 plus RT, or the other one. But let's try this one out and see how it works. So if we got 700 for your P, you got 1 plus R, which is 3%. So we got to change that to a decimal. And then the number of years, 6. Now you just want to be careful when you calculate this. Don't add that and then multiply it. You want to multiply first and then add. So order of operations. So we have 0.03 times 6, which is that, plus 1 is that. So 1.18. So we're basically saying 700 times 1.18, which we can do pretty quickly, times this by 700, and we get $826. So $826 is everything. That includes the interest and what you borrowed in the first place. So Kelly Cooner opened a security service on March 1st to pay for office furniture and guard dogs. Kelly borrowed $12,800 at the bank and agreed to pay the loan back in 10 months at 7% simple interest. Find the total amount required to repay the loan. So now they're trying to make it wordier and a little bit more confusing, but you still need to find those key ingredients to plug into the formula. So we know it's simple, and they want the total amount. So the total amount is the future. So we're still going to use that same formula. But now in this case, the principal is $12,800. The rate is 7%. And the time was what? Yeah, 10 months. Now, if you divide 10 divided by 12, so remember, this is just going to divide it by 12 to make it into years. So 10 divided by 12 equals the. Now, we don't want to round that to 0.8. We don't want to round it to 0.83. We want all of it as much as possible. So instead of using the decimal, let's use the fraction instead. And I'll show you how to do that on the calculator. Okay, so we still want to multiply that times that. Now remember, if you wanted to think of this as a fraction, you could if you just put it over 1. So really, all we got to do is multiply the tops and multiply the bottoms. But since the bottom is just times 1, we can just divide it by 12. So really, it's going to be 0.07 times 10 divided by 12 equals, and we get a yucky decimal. That's just the way it is. Keep the whole thing in your calculator. Next, we need to add the 1. So I hit equals after that. So we got 1.058, blah, 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 blah. But now the last step is to multiply it times the 12,000. So again, just times 12,800 equals, and again, you've not rounded anywhere in the problem, except now you need to round at the very end. And that's when you should always round, is at the very end. So we get 13,546.6666. So we should round that to 13,546.67. So that would be what she has to pay back at the end of those 10 months. So she better start securing some places and get some money back. So, all right. So that is simple interest. Now we're going to see this in other applications as we go. But for now, like I said, we just have those couple of formulas that you can choose from. You got your interest only, and then there's the future value. So we're going to come back to those more and more. See you in the next video for compound interest.